Hey everybody, this is Larry. This is day 4 of the Leetcode Daily Challenge. Hit the like button, hit the subscribe button, join me on Discord, let me know what you think about today. This problem. I spent today as part of my workout, what did I do? I just did a lot of stuff. I did squats, 195 or 200 pounds. So I'm getting up there. Hopefully try to discover where my limit is. I'm just still warming up and doing a linear progression. My bench is kind of awkward, but I think I have some shoulder issues that I might have to work with a physical therapist to figure out. But and some of it is just getting old. It is what it is. But yeah, let's take a look at today's problem. Let's see what's going on. We have 1780. Check if number is a sum of powers of 3. Okay. Sum of the powers of 3. Okay. So, it's an awkward one, but I don't think it's that bad. I think the way that I would think about it first, right, is what isn't a power of 3? Oh, I guess if you have, I see. I think this one's a little bit awkward phrasing. I think the important word, or the I don't know if it's important. I mean, it is definitely important, but the differentiating word for me is distinct, right? I think distinct is the key word for this problem, because if not, then my first inclination, and that's why I was a little bit confused, is that any number could be powers of 3, right? It's just writing the number in base 3, right? And just like any number can be represented as sum of powers in powers of 2, right? That's just binary numbers. But distinct changes it a little bit. I was a little bit less confused, especially looking through these, right? The idea here, of course, is just that, and you probably don't need to know this per se, maybe, I don't know. Sometimes, and I'm not gonna lie, sometimes these things are so basic and so ingrained to me that I don't know what people know or don't know. So let me know in the comments if you think this is obvious knowledge and I'm just like, saying obvious things, or I should get deeper into it, or not make that assumption about like base 3 or something like that. And I'm not saying this to be mean or anything. I feel like sometimes I do have some blind spots around explaining certain things, because to me it just seems, I've been doing this for a long time, right? That said, so it just, for distinct powers of 3, it means that, well, it either exists or it has one representation of it, but not 2, right? So that means that if you look at it in terms of base 3, it's just whether all the base 3 numbers, or digits, if you will, base 3 digits are 0 or 1, meaning that there are no 2's in the power of 3. And once you kind of represent it that way and think about it that way, the implementation, I think, is a little bit cleaner. I mean, you can probably reason it out anyway without all the things that I said. Like, you could probably, I don't know, do it some iterative way or something. But I think if you have that foundation and you have that kind of, I don't think I would call it visualization, but for me it is kind of visualization, honestly. I mean, it's not visualization in the same way that you draw a graph or you draw something, but for me it's just seeing the number now as a ternary number, or base 3 number. It allows me to kind of think, okay, well, what do I want to do? Well, then just get one digit at a time, right? How do I get one digit at a time? Well, one digit at a time on a base X for some A, or base B, maybe base B for some B, is pretty standard, right? I was gonna say straightforward and then standard, and it got straightforward, which I don't know. I'm just weird, but yeah, it should be straightforward, or at least something that at least you could Google about, maybe, right? So that if you're stuck at home, not and learning, not if you're in an interview, because then that's that's a little bit of a I don't know. I mean, I guess if you have to, but that's just a little bit too late, is my point, in terms of learning anyway. So okay, so yeah, so we just have to get one digit at a time, and the way that I would write this is just something like this to get the last digit, right? So yeah, so maybe B is equal to this for D for digit, I don't know, and then you shift by 3, right? You shift in base 3. And then if D is, and you can write this in, I don't know, maybe I'll write this awkwardly. If D is equal to 2, then we return false. Otherwise, we just return true, right? Otherwise, that means that this entire loop is true where D is either 1 or 0. And yeah, this is also part of the kind of loop invariant type thing. So yeah, overall, I mean, I think this is pretty okay, right? Oh, 1799. That's almost a even number. So I guess tomorrow I'll be surprised anyway, because I mean, who keeps track of these things? But it's still a round number is a round number. Why did I click on that? But yeah, that is mostly what I have for this one. I'm just clicking. I click on contest some days because sometimes there's a button for you to click for points. Not today though. Yeah. So what is the complexity of this, right? You may ask. Well, if you want to be really specific, it's just base 3 of, log of base 3 of n, right? Which is, what does that mean? Well, it's a little bit nuanced because people say n to mean the size of the input in general in complexity, right? Not the number n, which is a different thing. So if you look at it in terms of the size of the input, well, the size of the input is going to be log n, let's just call this, I don't know, let's just call this D for now, so I don't keep on saying N and confusing people, right? I know that I have a second D, so that's a little bit confusing. Just go digit. Oh, yeah, I actually replaced it in the wrong place. Okay, right. So the number of the size of the input is actually log D, right? Because you represent D as a binary number. So N is going to be log D, as N is the size of the input. And if D is, say, I don't know, 1,000,000, then it takes 20 bits, right? To represent it. So that is linear in size of that. What about this algorithm, right? Well, this is, and if you want to work back, there are a couple of ways you could work at it, right? You could work backwards from log base 3 of D. So then you kind of work it together, and you'll probably come up with something like log 3 of something like I don't know. I don't remember which way. That's why I'm a little confused. But like log. Well, yeah, it's a constant, right? So you have log 3 over log 2 and something like this, and that you can kind of reduce that, and it becomes a constant, so it becomes O of log D, right? Of course, O of log D is just O of n, right? Because n is the size of the input. So this is linear time, and well, I guess if you really want to be precise that way, it's a little bit awkward as well. So it's not quite linear time because the shift also takes linear time. So if you really want to be precise, it's actually n squared quadratic time. And the way, I mean, for small numbers, especially for this input, it doesn't matter. But you can imagine D is a huge number, like you're using big nums, right? If you're using big number, big integer or whatever, then this loop will be O of n, right? So you have like a 1,000,000 digit number. This will be O of n, and the shift will be also O of n, right? And also maybe even mod, honestly. So I mean, the mod 3 you could do it a little bit smarter, but not much, right? So this is actually n squared. I actually misspoke earlier. So yeah, because I just didn't really think about it. I don't really think about this often because for small numbers it's fast enough. But if you want to be really precise, that's the way I would think about it. But yeah, that is all I have for this one. Let me know what you think. Thanks for watching, and yeah, let's have a great week, everybody. It's Monday. Maybe Tuesday by the time you watch this. Stay good, stay healthy to your mental health. I'll see y'all later and take care. Bye bye.